Hi ladies, in this video we're going to go through the challenging questions or the difficult questions for negative indices, but before we do, just recapping the key ideas. And I was explaining to a student the other day why this works, so I thought I'd just quickly show you. So let's say if we had 1 over x to the power of negative 1. Now 1, if you were to write it as an index, is any base to the power of 0. So because we've got x down the bottom, I'm just going to write that it's x to the power of 0 divided by x to the negative 1. Okay, so I've added the x to the power of 0. It's the same as 1. I haven't changed anything. I'm just basically wanting to prove to you why this works. Okay, so when we're dividing, we keep the first term, x to the power of 0, and we subtract the power of the other term that we're dividing by. So remember back to, I think it was index law number 2, when we're dividing, we subtract our powers. So I'm going to subtract negative 1. So x to the power of 0 minus negative 1. So 2 negatives gives us a positive. So it's just x to the power of 1, which just gives us x. Okay, so remembering that might help you. You don't have to do it that way, but sometimes people like to have an understanding of how things work. So that's one way of showing how it works. Now, just one more thing before I get on to the challenging questions. If you had a to the negative 1 over b to the negative 1, they basically just switch. Okay, so b comes up the top as a positive power and a goes down to the bottom as with a positive power. If you had a coefficient and over b to the negative 1, the power is only for the a, so the 2 stays up the top. Okay, so it becomes 2b over a. Okay, so the 2 doesn't have a power. The only time it would switch is if it was in brackets, and that bracket was to the negative 1. Sorry, I should have written a. Let's be consistent. So you'd have then b on the top and the 2a on the bottom because that index applies to that bracket. All right, let's go ahead and do some difficult questions. So the other video already covered those questions, so we're going to look at some more difficult questions now. Let's get rid of all this. Okay, so question 6. So we're doing it without a calculator. I'm going to skip some of the easier ones and maybe move and start with J. Now, if you're only doing half the questions or a third of the questions, don't just do the first easy lot. Either do a full column or just do every fourth one, whatever, but you need a mix. You can't just stop, because I was helping my son last night with his work, and he was doing half, but he was like, let's say there was 8 questions, he was doing the first 4, and I'm like, you're doing the 4 easier ones, you're not getting a chance at doing the harder ones. So make sure you get a chance to do these harder ones down the bottom. All right, so let's start off with J. I'm just choosing them at random. So times 2. So we're going to use a multiple index laws here. So 8 to the negative 7, whoops, it's a 7. And then when you've got a power to a power, we're going to multiply them. So 2 times 3 gives you 6. Now, you could put the 8 to the power of negative 7 as a positive power now, but I would keep the base. Okay, so it's not 8 times 8, it's just the base 8, and then we deal with the powers. When we're multiplying, we add our powers, so it's negative 7 plus 6, which gives you 8 to the negative 1. So negative 7 plus 6 is 8 to the negative 1. And then using our index laws, that becomes 1 over 8. Okay, so the inverse of 8, basically 8 to the negative 1, becomes 1 over 8. So doing your multiplication first and then converting into a positive power, because if this power was greater than 7, then you would end up with a positive power. So easier to do it at the end, convert your negative powers to positive at the end. All right, let's have a look at M. Whoops. 1 over 8 to the negative 1. So anything with a negative index switches. So when you're looking at a fraction, if it's on the denominator, it comes up onto the numerator. So the 1 stays there, and I'm just writing that because if it was another number, it wouldn't stay there. So if it was a 2, it would stay there, whatever. And then the 8 comes up to the top as a positive 8, so 1 times 8, and then we're just left with 1 on the bottom. Now, we don't tend to write 1 times 8, we just write 8, and we don't tend to write divided by 1. So your answer is just 8. So 1 over 8, the negative 1, just becomes 8. And we did something similar at the start of this video, but I used x. So I proved why that was. All right, so looking at p, so this time we've got a numerator that is not 1, it's 2, and then our denominator we have to the negative 3. Now, you can bring that 2 up, but you can also do it a different way. So this is the same as 2 to the power of 1 divided by 2 to the negative 3. And remember, when we divide, we subtract our powers. So it's going to be 1 minus negative 3, which gives you 2 to the power of 4. And it says evaluate, so I'm going to actually have to do that. So that's 2 times 2 times 2 times 2. So 2 times 2 gives you 4, times 2 again gives you 8, and then times 2 again gives you 16. So 2 to the power of 4 gives you 16. Now, if you wanted to, you could do it a different way. So let me just cross that so we know it's separate. So the 2, and we can bring that 2 to the negative 3 up the top. So it's 2 to the power of positive 3. Now we've got the 1, so it's 2 to the power of 4. So pretty much the same thing, getting to the same spot, but just showing you it works that way. Yeah, I was just thinking aloud, thinking in my head. Where else do you think? Okay, let's do another question. What did I just do? P. So let's have a look at S. So I'm going to try to do as many different ones as I can, although P and M were very similar. Okay, so the negative 2. So when you have this power out the front of your bracket, and you've got a fraction within the brackets, the negative 2 applies to the 3 and the 8. So it's going to be 3 to the negative 2 over 8 to the negative 2. Now, to get them as positive indices, we just switch. So the 8 will come up to the top and the 3 comes down to the bottom. And that's only because they're both negative. If one was positive, it would just stay there. Okay, so the 3 negative 2 comes down the bottom as 3 to the power of positive 2, and the 8 comes up to the top as 8 to the power of positive 2. Okay, so we're going to evaluate it. So it didn't say to leave it in index form. So let's do it. 8 squared is 64, and 3 squared is 9, and I don't think we can simplify that any further. So it's just become 64 over 9. You don't need to put it as a mixed number fraction. Okay, let's have a look at W, and then I might do Z. So they're look a little bit harder. Now, just be careful with your powers that they clearly look like they're up the top. Okay, so let's just get rid of these brackets first. So negative 2 is my base. Now, if my base was a negative, I would put it in brackets just so I don't get mixed up with my negatives. And I'll explain why in a sec. So negative 3 times negative 3 gives you a positive 9. And then on the bottom, is that just positive 2? Okay, so remember when we take a negative base to an odd index, your answer is going to be negative. But if it was to an even index, it becomes positive. So that's why I keep them in brackets. Excuse me. Okay, so then we've got 2 to the power of negative 2 times negative 4 gives you 8. So remember your index law, when there's a power to a power, we multiply our powers. Now, negative 2 to the power of 9 is going to be a negative number. 2 to the power of 9, oh my gosh, let's keep doubling. So 2, 4, 8, 16, 32, 64, 128, 256, 512. And yes, girls, I was using my fingers as I was doing that. And then 2 to the power, what have I done? Have you noticed that what I've done? Oh gosh, I can't believe I made that mistake. So, I just realized then. So what this is the same as is negative 2 to the power of 9 over 2 to the power of 8. So we've got negative 2 to the power of 9 minus 8, which just gives you negative 2 to the power of 1, which is negative 2. So a lot easier than using my fingers to do those powers, and I can't believe I didn't pick that up. Okay, so much easier to do it the second way, girls, but as you can see, you get the same answer. So all good. All right, let's do last one, x. All right, writing it carefully as well. And I'm not saying it as I do it because I'm really concentrating. Oops, I just made a mistake, I noticed. Sorry, let's just get rid of those brackets. That should have been around the whole thing. Where's my pen? Okay, so around the whole thing. There we go. All right, so this negative 1 applies to the numerator and the denominator. So let's do that first. So negative 4 times negative 1 gives you positive 4. And then negative 2 times 1 gives you, negative 1 gives you positive 2. And then we've got 7 to the power of 1 times 4. And then negative 1 to the negative 4 gives you 2 to the power of 4. Okay, so we don't need to flip anything because of that negative power out the front. All right, so now we've got, I'm going to just bring everything together on the numerator and the denominator. Did I write that? Okay, cool. 7 squared, just making sure. Now, this 2 to the power of 4 cancels with this 2 to the power of 4. Didn't realize I wrote it in order. And then 7 to the power of 2 brings that down to 7. So we're left with 7 to the power of 2, which is just 49. All right, have a look at question 8. So question 8 requires you to think a little bit. So we've got, for question A, 2 to the power of x equals 1 over 16. Now, when you're doing something like this, if you wanted to, write both sides as the power, the base of x. So 16, I can rewrite as 2 to the power of 4. 2, 4, 8, 16, good. Okay, so 2 to the power of 4. Then I need to write this as not 1 over, but base 2. Okay, so need to write it the same way. So it's going to be 2 to the negative 4. So that means x is equal to negative 4. Okay, so these are a little bit harder. What do we got next? So 5x, let's do B. 5 to the power of x equals 1 over 625. So they do seem like big numbers, but it doesn't actually take you long to get to that number. So we're going to leave it as 5x and then write 1 over 5 and then work out what our power is. So we've got 5, 25, 125, okay, and then 625. So 5 to the power of 4 gives you 625. Writing that right-hand side as a positive with a negative index gives you 5 to the negative 4. So that means x is equal to negative 4. All right, let's have a look at F. All right, I did 8F, but I'm going to do it hopefully an easier way than what I was just doing. So 3 times 2 to the power of 2x equals 0.75. Now, I find it a lot easier to write the decimal as a fraction. So that's the same as 3 over 4. So basically what we have, and I might just write this again over this side. Sorry, the right-hand side. I'm going to write as 3 times 1 over 4. So I've got the 3 and the 3 on both sides. So if I divided both sides by 3, they actually cancel out. So then I'm left with, just bear with me, 2 to the power of 2x is equal to 1/4. So the quarter I can rewrite as 1 over 2 squared because the 4 is the same as 2 squared. And because we are solving for base 2, I need to get base 2 on the right-hand side. So 1 over 2 squared becomes just 2 to the power of -2. So then now that we have our same bases, we just let our indices equal each other. So 2x is equal to -2. Divide both sides by 2 to get x by itself. So x is equal to -1. Okay, so quite a difficult question, and took me maybe 2 goes, three goes to do that, or to explain it in a clear way. All right, girls. If you're doing question E and question D, convert them into fractions. It'll make it a lot easier for you. So 0.5, write it as a half, and 0.2 is the same as a fifth, and it'll be a bit easier for you. And 25, you should write as 5 squared. Okay, so just a few hints for you. All right, girls, bye.